Today we'll design a system for web crawler. So let's try to understand the problem, and then we'll think about the solutions, and then we'll discuss more on that. So the problem is, the web crawler. So there are millions of websites, and we need to find out some data from the millions of website. Like maybe the websites can fall under some category, like let's say that's all the news channels, all the news websites, and from there we need to get the data. Or maybe it's like the Google, like the search engine. So for the search engine, if you search something, then it will search in millions of the website, and from there it extract the required data, and then it displays that. So we need to design a system to achieve that. So we already know the use case of this, like the search engine, or maybe for we want to collect the data for data analysis. So we want to fetch the data from the millions of websites. So that's the problem. So there are many websites. So let's consider. Let me So let's consider there are 100 million websites. Just for the calculation, just I put the 100 million, easy calculation. Yeah, so it can be in a billion also, but just assume there are 100 million websites, and we want to extract the data from there, and we want to save that in a database so that the further we can process the data. So in that case, we need to find out, like, when we get the data, what will be the memory size we need to store the data. Let's say we want to store the data in our database, or in a file, or in a S3 bucket. So if you want to store, how much data we need. So for the 100 million websites, we know if you visit some website, like any website, then there will be different link over there. If you click on that link, it will redirect to another internal page, or maybe it can redirect to another website itself. So in that case, just assume in a average, like one website has like 100 internal sites. So I can just say 100 internal pages, I can say. So one website has 100 internal pages. So now we have 100 million into 100 internal sites. So we need to crawl all these sites there, and let's say there will be like 100 KB of data in each page. We want to extract just the data. We do not care about the image or the video files, but we care about the data. So in a data, consider like in an average one page has 100 KB of the data. So in that way, if you want to calculate, this is like 100 million into 100 into 100, and if you convert to, this is the kilobyte, so kilobyte to GB. So in that way, like the 100 millions, if you make 30, that turns to the MB, and another 30, it turns to the GB. So you can see here like 100 GB, 100 GB, because it's 100 million. So in the million has 100 million, there's a 60, so the 30 that turns to KB to MB, another 30 GB, so 100 GB into 100 into 100, and it should be, again if you take the 30, then remaining will be 30, so the 30, you can say that's a terabyte, and you can say 1 petabyte, 1 petabyte of data. So 1 petabyte of memory we need, for this to crawl, the 100 million of pages. So that's the one thing we figure out about the space. What is the space we need? So that's we calculated that. Next thing, let's try to think where we can start to crawl all the web pages. So here in this case, like 100 million website, I say the 100 million websites is I can just say that's a seed URL. So there will be process, so there will be process for seed URLs. So these are 100 millions are seed URLs. And also in a seed URLs, when we process this, so there will be one process here, we write the code that that is going to get like 100 million URLs. Maybe we get from third party, we can get from some the DB somewhere, or from some file we get that. So seed URLs, this process will get that seed URLs. So once we get the seed URLs, then this process also send one by one to queue, because I need a queue here because I want to process this one by one. Then it's going to take a lot of time to process 100 million. But instead what I want, I want to put that in a queue. So if I put that in a queue, then I will have the multiple processes that take from the queue. So the multiple process, in the sense I can say multiple workers that take the data and run at the same time. So we can do the distributed processing, or we can do that with the like horizontal scaling. We can have like more process that's work on the queue. So that's why, just let me put that here. I can just say that's a queue. That's the queue. So seed URLs responsibilities, put all the seed URLs in the queue, and from the queue there will be HTML. I can just say the HTML parser, because this website contains the HTML data. So let's have one process, and for this process I just say this one is HTML parser. So just parse the data when it gets from the queue. The HTML parsers get the data from the queue and parse the data. So yeah, so here in this case, if we have only one parser, then it will take one URL from here and parse that, and it takes one by one. It takes a lot of time. So here in this case, we need to do horizontal scaling. We need to decide like how many HTML parser we need, how many instance of that, maybe 1,000 instance or 2,000 instance, so that all the instances get the data from the queue and start processing parallelly. So that's a distributed processing, right? So I'm not showing all the box here, but you can just understand here. This can be many HTML parser. So one more thing just I want to add here, like when we get URL from here, so HTML parser will get the URL from the queue and start processing, but there is many internal steps to get the data from this URL. From the URL there are many steps to find the exact IP address and go there and then get the data from there. So in this case, either we can use some DNS resolver. That DNS resolver locally, customized kind of DNS resolver. And if you use that, when we get this website, we can just pass to the DNS resolver, and it can quickly give us the IP address, and then from there we can extract the data. So for that, let me put here, it's I can just say customized DNS resolver. So we understand why we need that. If you do not use that, then we get the website and hit that, and internally it takes some time to extract exactly what's the IP address for that. So that's why just I'm using here customize DNS resolver, so we can customize that and get use of this DNS resolver. So in this way, okay, till here we got the data. So that's a multiple HTML parser here, and we extracted the data. So once we extract the data, we can put that in a, for now I can just say we just put that in a S3 bucket. So let me put that, I can just say this one, S3 bucket. Okay, so let me show this S3 bucket with a different diagram, maybe this one, S3 bucket. Okay, so there are few challenges here, like before putting this data to the S3 bucket or database, or maybe some data we may use the Redis, but yeah, that's based on the different scenarios. But for now, just consider we put that data in a S3 bucket. So this the problem can be the same data can be duplicated. So duplicate data, there is chance of getting the same data again and again. So how we'll get the same data again and again? So when HTML parser read the data from one URL, and maybe another HTML parser hits another URL, and that another URL has some internal pages, and that point to the again same URL. In that case, we get the same data, and if you put the same data again and again, we are going to waste a lot of memory here. So we need to avoid that. So we need to check whether two things we need to check. One thing is we need to check the URL. The URL itself is same. So if you detect duplicate URLs, then we need to avoid that. So that's the one thing. And then other thing is, if the data is duplicate itself, maybe the two URLs have the same data, exact same data, so you need to avoid that. So for that we need to have another process. So let me add here some process here, and I can just say check duplicate entry. Let me bring this thing. Okay, so HTML parser, before storing to the S3 bucket, somehow it will call this process check duplicate entry, and if the entry is duplicate, then we'll not store that. And this process we can have another process for checking checking the site itself if the duplicate URL. So if it is a duplicate URL, then we need to avoid that also. Okay, so let me add another process here. Is for duplicate URLs, and let me bring one more curve because this data comes from here. HTML parser has the data, HTML data, that's exact raw data what we need, and also it has the duplicate URLs, so that comes from here. So let me duplicate this, and I can point one of this here. This goes here. Okay, so yeah, we got the idea, right? So from here we get the duplicate entries. Now, so we need to check the duplicate entries here. So how to check the duplicate entries? There is this process. We'll check that. Maybe we can put we can store that in a key value pair hash map. So we can do that in a hash map. Hash map is very efficient, but there may be the key collision over there when hash key collision. So in that case, like normally we do not see, but in any programming language, like I can just say, for the example, in a Golang, like if you see if your hash table, where in a Golang we use the map, and internal data structure is hash map, but when there is a key collision, then in that case it will be slow. So in that case, like if you find that kind of scenario, there is another data structure that's called Bloom filter. So you can use that Bloom filter also, or maybe you can use the combination of both to check duplicate entries of the URLs. Okay, if it is not the duplicate and it's a new URL, it's not duplicate, then we need to process that. So somehow that has to come to here, and this is responsible for just seed URL. So then let's have another box here, and this we or let me delete from here. I can just say, so this box I can just say URL populator. So URL populator, from here if you find okay, that's the unique URL, then this process is responsible for that, collecting that URL populator, and then this data will go to the queue again. So like a seed URLs, from the seed URLs we get 100 million of URLs one by one, and under that if there are any other URLs, then we can send those URLs through URL populator. So we need to have one more link here to the queue. Yeah, so in this way that data comes to this place. So this is the exact the functionality of this, and based on the requirement we can add different process here, or you can get rid of some of the process we can do. But there can be another requirement, like when we extract the data from web pages, there are many static pages where you get the same data again and again, and some of the web pages where data gets changed. That's the data getting changed dynamically. So we need to handle that also. We need to schedule this in a some manner, so that every time, like when you detect that that kind of websites, or maybe for the static also, if the static data may change, it changes very rarely, maybe year 2 year, but mostly for dynamic URLs. In that case also, we need to have some process, so detect those things and schedule that, so that we can paste the data again and again. So for that, just I'm going to put one more process here, and I can just say this is the scheduler, and connect these two here. So this is the picture of designing the web crawler. So yeah, so that's all I see. Yeah, so that's all for now. Thank you.